The chapter is triangles for standard 9. The question is in a rhombus ABCD, O is any interior point such that OA is equal to OC. So this is the point O, it is any point. So OA is equal to OC is given. Then prove that DOB are collinear. So now you have to prove that DOB is collinear. That means all the points will fall on a straight line. So now we'll join OD and OB. Join OD and OB. Now let us consider the triangle AOB and COB. That is, these two triangles we will consider. Consider triangle AOB and triangle BOC. So this triangle AO is equal to CO. CO given. Now AB is equal to BC because all the sides in a rhombus are equal. AB equal to BC side. Now BO is common side. Here AB equal to BC, sides of a rhombus. Sides of a rhombus are equal. So now these two triangles are by SSS congruence. These triangles are congruent. So triangle AOB. Now when you write it, you have to write it in proper sequence. Now AO and CO are equal. So we will write it as AOB means COB. You have to write COB. SSS congruence. From this you will get these angle AO. From this you will get angle AOB is equal to COB. So angle AOB is equal to angle COB. So when you write this congruence, you have to write it in proper order. Then only you will get the corresponding parts. So CPCT, we will get these two angles are equal. Angle AOB. So I will just write angle 1 and angle, this is angle 2. Angle 1 is equal to angle 2. Similarly, we can prove triangle AOD is congruent to triangle COD. We can prove this also. These two triangles are also equal. So we don't have to prove it. You can simply write triangle AOD is congruent to triangle COD. From that we will get angle AOD is equal to angle COD. Again it is because of CPCT. Here it will be again SSS congruence. So I will just write this as angle 3 and angle 4. So that means angle 3 is equal to angle 4. Now we know that angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360. All angles around a point is 360. Sum of all angles around a point. So I will write this as now we have 1 equal to 2 and 3 equal to 4. So I will write 1 and 2 as 1 is equal to 2. So I will write it as angle twice angle 1 and 3 and 4 are equal. So I'll write it as twice angle 3 is equal to 360. So twice angle 1 plus angle 3 is equal to 360. So angle 1 plus angle 3 is equal to 360 by 2 is equal to 180 degrees. So we got angle 1 and angle 3. These together is 180. That means they are linear pairs. Therefore, angle 1 and angle 3 are linear pairs. Therefore, DOB are collinear. Here in this problem it's given this line L is parallel to line M and M is the midpoint of AB. This. So M is the midpoint, so AM is equal to MB. Show that M is also the midpoint of any line segment CD having its end points on L and M respectively. So C is any point on L and D is any point of M, and CD we have to prove that M is the midpoint of CD. That is, we have to prove CM, you have to prove CM is equal to MD. So let us consider these two triangles. Consider triangle AMC and triangle BMD. So AM is equal to BM is already given as. Now we have these two lines are parallel. So we can say this angle and these two angles are alternate interior angles. I'll give this angle as angle 1 and this as angle 2. So angle 1 is equal to angle 2 A. So, because L is parallel to M, alternate interior angles. Now we have these two angles are equal, vertically opposite angles. So I'll write this as 3 and 4. So angle 3 is equal to angle 4. Okay, I should have written this here first and then this. So angle 3 equal to angle 4. Again angle A is vertically opposite angles. So we have A as A. So therefore triangle AMC is congruent to AMC is congruent to AM, corresponding side is BM. So triangle BMC. From this is congruence is ASA congruence. Angle, side, angle. From this we can say CM BMD. Sorry. Now from this we can say CM is equal to CM is equal to DM. So or MD. CPCT, and we have proved CM is equal to MD. Here it's given ABC is a right triangle. So here right angle at A, and AB is equal to AC is given, and AD is the angle bisector of angle A. It means I'll give this angle as angle 1 and this as angle 2. So 1 is equal to 2. Now we have to prove BC is equal to twice AD. BC is equal to twice AD. Now since AB is equal to AC, we can say angle 3 is equal to angle 4. So this is given as angle 3 and this as angle 4. So angle 3 is equal to angle 4. The reason is AB is equal to AC. Now this is 90 degrees. Therefore, angle 3 equal to angle 4. So these two both together will be 90 degrees because this is angle A is 90 degrees. So 3 plus 4 is equal to 90 degrees. But angle 3 plus angle 4 is equal to 90 degrees. Reason is angle A, angle sum property, angle A is equal to 90 degrees. So 3 is equal to 4. Therefore, we can say angle 3 is equal to angle 4 is equal to 45 degrees. Now, angle 1 is equal to angle 2. Angle A is 90 degrees. Therefore, angle 1 is equal to angle 2 is equal to 45 degrees. The reason is AD is angle bisector and angle A is equal to 90 degrees. So from this we get 1 is equal to 2 and that is equal to 45. 3 equal to 4, that is also 45. That means all the angles, this is 45, this is 45 and these two are also 45. If these two are 45, then we can say these two sides are equal, and similarly angle 2 and these two are 45 degrees. So these two are equal. So I can write it as BZ BC is equal to BD is equal to AD. The reason is angle 1 equal to angle 3. So I'll put like this. And similarly these two are equal. Therefore AD is equal to CD because angle 2 is equal to angle 4. Therefore, you can from this you can say these two are equal. Therefore, D is the midpoint of. Therefore, D is the. Therefore, BD is equal to CD. Now, BD is equal to half of BC. BD, or that means twice BD is equal to BC. Instead of BD, I can write is AD. So twice AD is equal to BC. That's what we have to prove. BC is equal to twice AD.